In this video, we will learn how to make simple animations in MATLAB and store the result in a video file. So the animation that we will be studying looks like this, and in this case the data consists of simulated data of Earth and the Moon location. Moon is orbiting around the Earth and plotting this nice trail behind it so that it's easy to follow where it has been previously. And all of this is stored in a video file in the disk. This is the target of this exercise. We can do this by this example code that has been provided for you. The code starts by reading the location data. It is a CSV file looking like this, so that there are approximately 600 rows in this file, and at each row there is the X, Y and Z coordinate of the Moon at different time points, and there are 600 time points in this file. And in the template provided, the for loop goes through all of the location time points, all of the 600 XYZ coordinate combinations in the file. And for each one of those, we are plotting the Earth location, assumed to be at the origin of the coordinate system, and the Moon location, extracted from the data loaded from the file, X, Y and Z coordinates. Moon is plotted by a blue circle, and the Earth at the center is plotted by a red circle, as shown in the video as well. Also some adjustments to the marker sizes and stuff so that it's better visible in the video. And notice that we are using the plot3 command, not the normal plot command, because we want to have a three-dimensional coordinate system, and thus the 3 at the end of the command line. Also, there are certain adjustments to make things better visible and more static in the axis, so that the axis don't change according to the location of the Moon at different times. And when we run this file, the end result looks like this, so that there is Earth at the center and Moon orbiting around it. But what is missing from this exercise is still the trail. We would like to have the trail that follows the Moon, so to be able to better visualize where the Moon has been in the previous instant and what does it orbit looks like. This can be added quite straightforwardly because we already have the previous locations. We would just want to show, let's say, 30 most recent previous locations of the Moon. And the Moon locations are loaded in here. And in this extended example, after plotting the Earth and Moon locations, just like in the previous script, we are additionally generating the trail. And the trail generation basically sets the hold to the on state, meaning that we don't wipe out the just plotted Moon and Earth locations. And then we just plot about 30 most recent Moon locations using a small blue dot, slightly smaller than the actual current location of the Moon. However, it might be that we are not able to access the 30 most recent data points. If we just start it, if we are at location number 1, then we cannot access 30 previous ones because they don't exist. Therefore, I need to limit the set of indices for the recent data points, such that it cannot go below 1, because the smallest index for any matrix would be 1, and if I'm accessing the Moon matrix at location -5, for example, then it crashes MATLAB or this script. Therefore, I'm not starting from k-30, but I'm starting from k-30 or 1, depending on if k-30 is smaller than 1 or not. So I'm taking the maximum of 1 and k-30. If this one is negative, then I'm choosing 1, and if k is above 31, then I'm choosing k-30, because that's totally good in the index greater than 0 in this case. And if I run this example, we can see that now there is the Moon orbiting around the Earth, and also the trail shown with smaller blue dots as we wanted, and the trail length is now 30 points altogether. What's still missing from this example is the video storage. And we can do video storage using the video writer command. And you can get more information about it using the help command or looking at MathWorks website where the video writer command is documented very well. If I'm looking at this document, in the beginning is the information what kind of objects this generates and what kind of file types are supported. But maybe the example at the bottom is the best source of information in this case, because in here we are doing exactly the same thing that we want to do now. First we open a video file. Here is the name of the result. Then we actually open the file, and we generate set of frames inside of a for loop, just like in our case. The orbit is generated inside of a for loop. And in this case, for each value of k, for each frame in our animation, we extract what is shown currently at the figure using the getFrame command. And this getFrame result is stored in here and further appended at the end of our current video file. So this video object is the same thing that was opened up here. And then at this point I add just one more frame at the end of the video sequence or movie. And once I'm finished, once I have generated all the frames, the only thing that remains is to close the file. And at this point essentially the end result is written to the disk. It might take a while to write it to the disk, but eventually there will be a video file stored to the disk, just like it was shown on the screen while generating the movie. So basically this is it. Just include the trail generation and the video file storage into the template MATLAB file and send the template, the resulting MATLAB script to the email address provided by the designated deadline. But please don't submit the actual video. It takes a lot of email space and we can generate it ourselves once we have the actual code. But that's it. Thank you.